9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year, class! Yay! I am glad that we are able to celebrate a Happy New Year this pandemic. Wishing you all the best. May I ask, what is your New Year's resolution? Do you want to be skinner? Do you want to be fatter? Do you want to be more beautiful? Do you want to be more intelligent or more productive? I would like to remind you all that the only person who can tell how successful you can be is you. So, if what you want to do makes you more successful, then do it. No one can stop you. I, your teacher, will support you all the way with all of my heart. Okay? So, we will fly. Now let's ride on a rocket. I believe I can fly. I believe I can touch the sky. Ayan. Soar high for your dreams, okay? So, what is our lesson for today? So, the topic for this week, the sixth week for the second quarter, is the second part of simplifying radical expression. Yours truly, Teacher Joseph Sakulias, is about to tackle about simplifying radical expressions. So now we are seeing the universe, the beauty of the universe. We can conquer the universe if we want to. Okay? So in our learning objectives, the following expectations, the first one is bang! You should be able to simplify radical expressions by rationalizing denominators. The second objective, wow! You should be able to simplify radical expressions by conjugation. The third expectation, yeah, you should be able to apply the concept in real life problems. And the last expectation, woohoo! You should be able to appreciate simplification of radical expression. Are you ready? Okay. We're starting off with the review, of course. So we need to go back what we have tackled last time. But before that, I'm gonna give you a trivia about Earth. Did you know that Earth is about 581 square root of 65,536 all over 35 minus square root of 361 times 10 raised to 4 miles from the sun and is 31,704 over square root of 16 miles in diameter. Okay, so do you know that trivia? So if we simplify this, we may have a long time to solve that, but yeah, it can do. It can do. It can be done. Okay, now let's review. Okay, last time we tackled about how to identify whether a radical expression is in the most simplified form if it has no perfect powers as factors of the radicand. For example, 32, square root of 32. Since 32 has a factor that is a perfect square, therefore we need to simplify it more. Okay? And then the second criteria, there are no fraction inside the radical. So if you have seen any denominator inside the radical sign, you need to simplify it more. And then the number three, no radicals in the denominator. If you have seen a radical sign um, on the denominator, you need to simplify it more. And then the last criteria, you have no doubt about your answer. Yes, of course, you need to be confident with your answer. Okay, we have the following properties of radicals. The first one is the nth root of the product of a and b is equal to the nth root of a and then the nth root of b. And then the second property, the nth root of the m root of p is equal to the product of the indices, the root of the product of the indices of p. Okay? And then the third property, nth root of p over q is equal to nth root of p over nth root of q. And then the fourth property, nth root of the mth root of the product of a and b is equal to the nth root of a raised to m times the nth root of b raised to m. Okay, we have four ways of simplifying radicals. And last time, I have tackled the first two methods in simplifying radical expressions, which are reducing the radicand and reducing the order of the radicals. And today, we'll be tackling about the conjugation and the rationalizing denominators. Okay, so here is the example of the first method, reducing the radicand. Square root of 50. So 50 is the radicand, therefore we need to simplify 50. How? By factoring out. Okay, so we need to determine the factor of 50 that is a perfect square. And that is 25. Okay, so 25 times 2 is equal to 50. And we are going to simplify this 25. Square root of 25 is 5, and then square root of 2. Now let's do the judgment. Okay, the first one. No perfect powers as factors of the radicand. Does 2 have factors that has a perfect square except 1? There are no one. Okay, so the second criteria, no fraction inside the radical. I haven't seen any fractions inside the radical sign. And then the number 3, no radicals in the denominator. No, it is not in a fraction form. So therefore, this is the most simplified form of square root of 50. Okay, now we have the second method, reducing the order of the radical or the index. Example, eighth root of a raised to 12. So we need to convert this into, I'm so sorry. So we need to factor out the a raised to 12. So a raised to 12 is a raised to 8 times a raised to 4. So we have the product rule in algebraic expression, specifically in exponent. Okay, so the product is, when you add the exponent. Okay, when the base is similar or the same and it is multiplication, we just have to add the exponent like 8 plus 4, and then the product will be a raised to 12. Okay, and we all know that a raised to 12 is a perfect eighth power. Okay, because a raised to 8 is 8 times 8 times 8 times 8, 8 times. Okay, so eighth root of a raised to 8 is a, and then eighth root of a raised to 4, since a raised to 4 doesn't have factors that is a perfect eighth power. So that's when we're going to reduce the index by converting this expression to rational exponent first. So a raised to 4 over 8. Okay, so the index will be the denominator, and then the exponent of the radicand will be the numerator, so 4 over 8. And then we all know that the lowest term of 4 over 8 is 1 half. Okay, and then go back to the radical expression that is square root of a. Therefore, the answer for eighth root of a raised to 12 is a square root of a. Okay? Okay, so today we'll be tackling about the third and fourth method in simplifying radical expressions, which are conjugation and rationalizing denominators. But before that, we're going to go back what you have learned last time or last year. Okay, so we have the first property of a radical expression. Yeah, in our example, when you see a fraction inside the radical sign, all you have to do is to separate it, okay? So the answer will be square root of 3 over square root of 8. That's all. And then the second property, okay, it's not working. Wait a minute. Okay, once again, when you see a fraction inside the radical sign, all you have to do is to separate the radical sign for each term. So square root for the numerator and square root for the denominator. And the second property is a property of an algebraic expression. When you multiply an expression by this fraction, which is, numerator and denominator has the same, which is when you divide this, for example, 3 over 3. Okay, the answer will be 1, right? Because whatever you divide an expression to itself, the answer will be 1. For example, 3 divided by 3 equals 1. And then when you multiply that 1 to an expression, the answer would be the expression itself, right? Like the identity property, right? The identity property of multiplication is 1. So whatever number you're going to multiply it with 1, the answer will be the same. Okay, so in our example, 3 over 3 will become 12 over 15, and then you're going to simplify it. So the answer will still be 4 over 5. Okay, so the next property is the property of the algebraic expression, which is the sum and difference of two terms. Okay, when you see two similar um, binomials, but they have different sign, the first one is minus, and the second one is plus, and vice versa, the product of that would be the square of the first term minus the square root. Sorry. When you multiply these two terms, these two similar terms, but they have different operation, minus and plus, the product will be m raised to 2 minus the square of the second term. Okay? Square of the first term minus the square of the second term. Remember that. We'll be using this concept to the conjugation. And then another property of a radical expression, you should not forget these concepts because it is very important to apply that. Okay, the example is 8 over 3 raised to 3 minus square root of 5. Okay, conjugation. Okay, look at this class. So 3 minus square root of 5. So in our rule, um, the most simplified form does not have radical sign on the denominator. Since our example has square root in the denominator, we need to remove that. How? By conjugation. As you can see, class, we have 3 minus square root of 5. We have two terms here, the 3 and the square root of 5. And then when you when you look at what we have tackled last time, the m raised to n and minus n raised to n, it can be. Okay, so we just have to multiply it by the identical of that. Okay, but they have different operation. So 3 minus square root of 5 will be multiplied by 3 plus square root of 5. Okay, so that's when conjugation occurs. And then we're going to do 3 square root of 5 on the denominator to make it balanced. The value of this expression will not be affected. Okay, so 3 plus square root of 5 over 3 square, 3 plus square root of 5 over 3 plus square root of 5. So the value of that expression will not be affected. Okay, so conjugation, when we multiply these two terms, the answer would be the square of the first term, which is 9. 3 squared is equal to 9. And then the square of the square root of 5, which is 5. Okay, so the radical sign will be removed. So that would be 9 minus square root of 5. Okay, and then the 8 and then the 3 plus square root of 5 will be multiplied as well. And then simplify it. Okay, so that's how conjugation works. Now let's go to the lesson proper. Okay, we have the first example. Square root of 3 over 2. In our rule, the most simplified form does not have fraction inside the radical sign. Since our example has a fraction inside the radical sign, we need to simplify it by rationalizing denominator. Okay, we're going to do one of the properties of radical expression, which is we're going to separate the radical sign in the numerator and in the denominator. So that would be square root of 3 and then square root of 2. Okay, the next rule, simplified radical expression does not have radical sign in the denominator. Since this has denominator here, we need to remove that by multiplying by square root of 2. Okay, in the numerator and the denominator, don't forget that. Okay, to not affect the value of that expression. And then we're going to multiply the radicand inside. So 3 times 2 will be 6. And then 2 times 2 is equal to 4. And we all know that the square root of 4 is 2. Okay? Sorry. Okay. So the square root of 4 is 2. So the answer is square root of 6 over 2. Another example. Cube root of 48 over cube root of 6. Okay, in our rules, a most simplified radical expression does not have radical sign in the denominator. So we need to remove that. How? Let's try to make it generalize. So since they have the same index, we're going to combine that. Since 48 and 6 is divisible, are divisible. Okay, so cube root of 48 over 6, we're going to divide that. 48 divided by 6 will be 8. And we all know that the cube root of 8 is 2 because 2 times 2 times 2. So the answer is 2. Another example. Cube root of 32 over 54. The first method is I separate the radical sign. So cube root of 32 over cube root of 54. And then I'm going to find, the factor of 32 and 54 that is a perfect cube. Okay, since our index is 3 cube, so perfect cube. So you need to multiply that number 3 times to make that number. Okay, in 32 we have 8 times 4, and then 8 is the perfect cube because 8 is equal to 2 times 2 times 2. I multiplied 2 3 times. And then in 54, we have 27 over 2 because 27 is the product of, multiplying number 3 3 times. Okay, so simplify it. Cube root of 8 is equal to 2, and then cube root of 27 is equal to 3. So what we have left is cube root of 4 over cube root of 2. We can combine this, okay, since they have the same index. So 4 over 2, we can just separate it. 2 over 3 times cube root of 4, cube root of 2, and then combine it. And then 4 divided by 2 is equal to 2, and then recombine it. So the answer is 2 cube root of 2 over 3. Next example. 6 fourth root of 3 over fourth root of 2. Okay, so since this is a little bit challenging, I just change the characteristic of our expression. So from radical expression, I change it to rational exponent. Okay, so the fourth root of 3 will be 3 raised to 1 fourth, and then the fourth root of 2 will be 2 raised to 1 fourth. And then I'm going to make this 1 because we must remove the radical expression. Okay, so the exponent of 2 must not be a fraction, so it must be whole number, at least 1. Okay, so the answer, we make the exponent of 2 1. Okay, so I'm just going to multiply the numerator and the denominator by 2 raised to 3 fourth. Okay, because 1 fourth times 3 fourth is equal to 4 over 4, which is 1. Okay, so multiply it both sides. So 6 raised to 3, and then why 8? Because I already simplified 2 raised to 3, okay? 2 raised to 3. The numerator, okay? 2 raised to 3 will become 8. And then the exponent left is 1/4. So since they have the same exponent now, I can just multiply the bases. Okay, so 3 times 8 and then raised to 1/4. Okay, and then multiplied by 6. And then the denominator, 2 raised to 1/4 plus 2 raised to 3/4. So 1/4 plus 3/4 is equal to 1. And then 3 times 8 is equal to 24. Uh-huh. So I divide 6 by 2. 6 divided by 2 is equal to 3. And then 24 raised to 1/4. And then I converted this rational exponent to radical expression. So the final answer is 3 and the fourth root of 24. Next example. The fifth root of 5 over 8. So I just separate the root. So fifth root of 5 over fifth root of 8. And then I converted it into rational exponent. So 5 raised to 1/5 and then 8 raised to 1/5. Okay? And then I'm going to multiply something by 8 raised to 1 over 5 to make the exponent 1. Okay? So that would be, um, also sorry, this is not correct. That should be 8. Okay? 8 raised to 3. Okay, wait a minute. Aha, I'm so sorry. I'm so sorry, I'm not correct. Wait a minute. Before we multiply something, I just, you know, I just simplify 8 because 8 is equal to 2 raised to 3. Okay? 2 raised to 3. Okay? You can just do that or not. It's up to you. As long as you are correct in using the properties, then your answer is always correct. Okay, so 8 is 2 raised to 3. Okay, and then that 3 will be multiplied by 1 over 5 because the exponent of 8 is 1 over 5. So 3 times 1 over 5 is equal to 3 over 5. So that is 5 raised to 1/5 over 2 raised to 3 over 5. And then I'm going to multiply something by 2 raised to 3 over 5 to make the exponent 1, and that is 2 over 5, of course. Okay, so I'm going to multiply the numerator and the denominator by 2 raised to 2 over 5 and then multiply. So 2 raised to 2 is 4, and then the exponent left is 1 over 5. So as you can see, they have the same exponent now. That's when I'm allowed to multiply the bases. And then 3 over 5 plus 2 over 5 is equal to 1. Okay, then 5 times 4 is equal to 20 raised to 1 over 5 over 2. And then I'm going to convert this rational exponent to radical expression. So the answer is fifth root of 20 over 2. Okay, do you understand the third method? Okay, practice. Are you able to simplify this radical expression? I'm giving you few minutes. You can pause this video. Time's up. Is your answer 2 square root of 7? If that's so, very good. We can now proceed to the last method. Okay, but before we proceed to the next and last method in simplifying radical expression, you need to remember that the product of the sum and difference of two binomials, the answer is the square of the first term minus the square of the second term. Just like that. Okay? We have the example on conjugation. 3 minus square root of 2. So what term are you going to multiply with 3 minus square root of 2 to cancel out this radical sign? It's 3 plus square root of 2, of course. So you just need to change the operation and then multiply it. So 3 minus square root of 2 times 3 plus square root of 2 is equal to the square of 3 minus the square of the square root of 2. And that is 3 squared is equal to 9. And then we all know that 2, the square root of 2 is 2 raised to 1 half. And then I multiplied by 2. So 2 times 1 half will become 2 over 2, and that is 1. 2 raised to 1, and that is 2. So when you see this radical sign square root and it is in the square, you just need to remove the radical sign. So that is 2. Okay, 9 minus 2 is equal to 7. That's all. That's how conjugation works again. Okay, we can now proceed to the last method. We have 3 over 2 minus square root of 3. Now, let's use the conjugation. So the conjugation of 2 minus square root of 3 is 2 plus square root of 3, of course. And then multiply numerator by the denominator by it. Okay? So that is 3 times 2 plus square root of 3. And then the denominator, the square of the first term, 2 square minus the square of the second term, which is square root of 3. And I changed this to rational exponent, which is 3 raised to 1 half and then raised to 2 because the square of the second term, okay? So 1 half times 2 is equal to 2 over 2, which is 1. So 3 raised to 1 is equal to 3. Okay, suffice it to say, when you square a square root, you just have to remove the square root. Okay, so that would become 2 squared, which is 4, and then minus 3. And then I distributed 3 to each term. So 3 times 2 is equal to 6. And then 3 times square root of 3 is equal to 3 square root of 3. Okay, so 4 minus 3 is equal to 1. And then the numerator divided by 1 is equal to 6 plus 3 square root of 3. Another example. 2 over square root of 7 plus square root of 5. Find the conjugation of square root of 7 plus square root of 5, which is square root of 7 minus square root of 5, and multiply numerator by the denominator by it. Okay? So the answer is 2, and then times square root of 7 minus square root of 5, and then the square of the first term, which is this, and then this. So we just have to remove the square root, so that would become 7 minus 5. Uh-huh. And that is 2. And then we divide 2 by 2, so that is 1. So the answer is square root of 7 minus square root of 5. Next example. 4 over square root of 6 over 2. Find the conjugation of square root of 6 plus 2, which is square root of 6 minus 2. And multiply numerator and denominator by it. Okay, so we're going to multiply 4 by square root of 6 over 2, and then the product of these terms are the square of the first term, which is we just have to remove the square root sign, and then square of the second term. So 6 raised to 1 half raised to 2 minus 2 square. So that would become 6 minus 4. Okay, and then 6 minus 4 is equal to 2, and then divide this. 4 divided by 2 is equal to 2. So the answer is 2 square root of 6 minus 2, and then I distributed 4 by each term. So 2 times square root of 6 will become 2 square root of 6, and then 2 um, divided by 2, 2 times negative 2 is equal to negative 4. So the final answer is 2 square root of 6 over 4. We have the last example, class. 5 over negative 4 plus square root of 5. Find the conjugation of that. Negative 4 plus square root of 5. That is negative 4 minus square root of 5. And multiply numerator and denominator by that. Okay? So 5 times negative 4 minus square root of 5, and then the product of that is the square of the first term, which is negative 4 squared, minus the square of the second term, which is the square of square root of 5. So the answer would be 16 minus 5. And then I distributed 5 to each term. So 5 times negative 4 is equal to negative 20. And then 5 times negative square root of 5 is negative 5 square root of 5. Okay, and then simplify it more. So the answer is 11. Okay. So the final answer will be negative 20 over Sorry. The answer is negative 20 minus 5 square root of 5 over 11. I'm so sorry, I forgot the sign. So you should be careful with the signs, okay? Because if you forgot to put a negative sign or so, your answer will be wrong. Okay? Now, let's summarize. Are you able to understand the lesson? Okay. A radical expression is in the most simplified form if it has no perfect powers as factors of the radicand, no fraction inside the radical, no radicals in the denominator, and you have no doubt about your answer. And we have different properties of radicals, which is the following. And then we have four ways of simplifying radicals. And last time we have tackled the first two methods, which are reducing the radicand and reducing the order of the radicals. And this week we have tackled about the third and fourth method in simplifying radical expression, which is the conjugation and rationalizing denominators. Okay, class, we have the following expected outputs for this week. We have the learning task, performance task, reflective journal, and summative test. Okay, this is the learning tasks. This is the performance task. And we have the reflective journal. You just have to write something about what you have learned. And we have the summative test. Okay? For modular, you are given the learning activity sheet that is a one-page paper and the summative assessment number 3. So if you have that, you're going to answer that on that paper. Okay? In online, these materials are available in Google Classroom. Okay? So these are the credits of the following video. So thank you so much for watching. I hope you learned something. Bye. See you next time.